In this lesson, let's try some examples to better understand the field force. First, I want to create a simple cloner. We want to control the cloner with the field force. Oh, sorry. Holding Alt. It's nice. Make it smaller in this direction. Nice tree. Okay, we add some cloning here. Make a cube a little bigger. For example, I want to make a randomized animation for that. You can assign the field force to that for creating that. It's very simple. Going to the field force is giving to the all object in a whole scene. If you didn't assign any fall off or field to that. And now I want to add a simple random to that. Simple random. And in this case, nothing happened because the random is affecting particles. In this case, we want to use a cloner. So we need to assign the dynamic to that because the field force are affecting the particles dynamic object in a semaphore. They go into the tag in a bullet rigid body. And if you create it, they are falling down because of the gravity. You can click in a mode, go into the project, and make the system gravity 0. And now, as we can see, the field force random are affecting the cloner. So in this example, you learn that you can assign your random to field force. And as you can see, you access the random. It's very interesting. You can scale it down, can change the parameter or speed that. As you can see, we have a speed in the random. So you have very control here. As you can see, these are actually the vector that control the velocity, rotation, and speed of that. Okay, so you can play with these settings that you learned before in a random. Just it. Another example that I can give you, it's very simple. You can control the dynamic object like this with a spline. It means, okay, I want to go in this direction. So, okay, as you can see, we have a cloner and we have a rigid body to that. I assign an arc here. This is our arc. Okay, make it a bigger. Nice. I want that, for example, this cloner go in this direction of arc. So we create a field force here. This is our field force. This is an infinite. That in a field force, you can click and drag this arc here. Nice. This is our field force. Bring it there. And as you can see, if this field force is going to the area of that spline, it will be showing you. Because in the field force, we have an area. Because if you assign, for example, a random effector, you just randomize everything. But you assign the field force object. So it tells you, okay, please give a area. Please, the field force tells you, please give that object inside me to control the all particles that are inside me. So the position of the field force and your particles, or in this case dynamics, are very important. So you can go to the field force, you can go the strengths, and as you can see, it's because in this case it is aligned, the curve is going aligned. So let's try what happened here. As you can see, it's in a reverse direction. It's very simple. You can go into the arc and the direction, you can invert the direction. And if you play again, as you can see, some particles are going that direction. So you can make the strings a bigger number to pull them out. As you can see, they're going in this direction. So you can control the particles exactly like this. Or you can assign in a force a little follow position, I think. Follow position, a little number here. Let's see. Now, as you can see, we have an slower thing. But as you can see, the particles are following the direction of this arc. So I just want to show you this idea that you can control the dynamic object in the color or anything with these arcs. And the placement of the field force is very important. I think you understand it because the field force, for example, if you assign the field force in this direction, yeah, it's working. Because the field force in this case is infinite. But if I select the field box, the area, as you can see, does not work. Because if you assign nothing, it's infinite. But if you assign the fall off, it means, okay, please affect our forces, field forces, just in this area. As you can see, we haven't fall off. So you understand it's very easy. We have a fall off here. Okay. Another interesting example of that is you can combine this with the volume builder. As I said before, in a volume builder, I will explain this vector in a future lesson, next lessons. It's a time to explain it. It's a vector. Interesting. It means you can assign the volume builder. You can go into the random field. Interesting thing that you can assign the random field to volume builder. Interesting. You can create something like this. And now we want to control our simulation emitter. It's here. It's our simulation emitter. Going to make it a higher number. We want to control our particles. If they reach to this area, we want to control it with this random with a volume builder. We make this 3D area moving inside that. So going to the forces, field forces, and in these objects, you can assign your volume builder. So you want to control as a volume object. It means you want to control. You want to control your, you can turn it off. It's you want to control your particles as a volume builder. Okay, let's try it here. Okay, this is our volume builder. Accidentally assign it in the field. Oh, be careful about that. Going to the object here. Be careful. Volume. And as you can see, it's changing the direction of your particles in this way. Nice. Okay. We can go into the field force. In a display, you can make a lower number of the display of lengths to better see it. You can assign the lower number. And as you can see, you can, if you play it, you can see it, all the particles are flying back. You can go your particle inside it. We have very power of that. You can control it if you want. Okay, go to the field force. We can change density. As you can see, we have lots of that. Strength 1. And as you can see, the particles are changing the direction. So in this lesson, just want to tell you, okay, you can use the volume builder to controlling, as you can see. Oh, sorry. First, I have to turn the volume type to the vector. Now it's nice. Now it's nice. I have to change the volume builder mode to see it, as you can see, and now it's correct. I forget that you have to change the volume builder at the vector and make the number back. And now you can see the difference between that. It's an emitter, field force, yeah. Okay, select our emitter, bring it there. That's what happened. As you can see, they are changing the position of that, but it's not very strings. Change it again. Now you can see we haven't changing the rotation, the position and direction of your particles if they're reaching this. Okay, that's nice. Or you can bring it there. Nice. So this is the vector mode of that. Here you can change the voxel size of that to make it a smaller number of the direction. We have more changing of direction, okay? If you change the voxel size. If you want to fewer randomize, you can change the voxel size here. So you learned these vectors are for assigning, for changing the direction of the particles or dynamics. That's it. They're just visual display for changing the direction of your particles like this, with more scale or lower scale. You can do the volume builder, the field force, click on volume builder. You can assign to the other settings. Okay, that's nice. Okay, that's it. Let's do another example. Let's begin another scene. I bring another emitter. Like before, it's nice. Let's go for small. We add a speed in a 0. And let's try it. We have a more birth rate for particles to see it better. Nice. Increase the number of the frames to better playing. Okay, as you can see, they are birthing embers. So we bring a field force exactly at the position of the position of the emitters. Yeah, you can double the size of your emitter here. Nice. To fit the area of the field force, and then the field force in the display you can 0 for making to the 2D. It's affecting the 2D, and the field force is empty. In a field force, it's interesting thing that you can assign in an object anything that you want. For example, first I assign the random to that, and I turn it off to see it better. As you can see, they're randomizing the position of your particles. Or after that, you can assign a modifier to that. For example, a delay or decay effector and delay effector. And you can assign a fall off, for example, a sphere fall off. Make it smaller. Nice. You can go to the object. As you can see, it's normal, so it's automatically turn the random. And let's see what happened. Sorry, you can move your I think move the, as you can see, it does not anything because in a field force it's add to velocity. You can change it direction if you want. because there are no speed, they are not working. So go to the random, yeah, add the velocity here and turn the random, and now you can see it. It's both normal, and as you can see, you can change the position of that. You can go to, and I want to explain. You can subtract them, add them, multiply them. You can do something like this in a spherical mode to see the difference. As you can see, we have a delay to its positioning, or you can of course assign another delay to that decay, another delay or formula, anything that's you want. You can try the that's the delay. We have a decay. Let's try the decay. What happened here? It's a decay. And don't forget to combine them and see what happened there. Nice. As you can see, if we move it, we have a delay to move it. As you can see, because as you can see, there are delay in changing the emitter is birthing its particles, because in a field force, we assign the fall off just inside this area that assign the field on this with these objects, a random and a decay. Just this area changing their position of the particle with a random. It means in this area, just a random will be affected. And because we add don't forget into playing with the blending modes, the random will be affected with a delay or decay here. You can select it and simply move it. As you can see, with a delay, there will be changing the position. And the random effector will be affected there. Nice. Let's explain the mask in this. It's very important. Okay, it is our emitter. It's birthing there. I create an arc here that you can make it this number here. I want to change the direction of this particle by arc. You can click and drag an arc here and delay the decay here. Go into the display and more density. And as you can see, because of this, the center of the arc, it's changing the direction from here to there. So we don't want that. We want to change it along that. So we go into the arc. In a layer, we are going to the radius. If you say to the radius, it does not work because it's the particles going in this direction. But we want to particle attracting to this spline and then going up. So what we can do? So here I have to explain the mask. Here you can understand the mask. First, we want to particle going align the curve. So this first arc, assign it to the align. And we don't want to all particles going along that. For example, they are going to bad direction. This is an emitter, the particle. Yeah, we have no speed. You can go into the arc and reverse it. And as you can see, we can reverse the direction of arc or direction of the field force in here. Go into the arc, change the direction. You can do both things. And as you can see, they are going in this direction. Nice. It's in the field force. And everything is correct. Okay. Now we want to mask it. We want to tell the field force, okay, just assign the particle around this. So we need a mask. We want to mask this arc. Click a mask, it's child of that. Mask this arc exactly with that arc. We click and drag another arc under the mask. Okay. And in this arc, we have to tell, okay, go to the layer, not align. In this case, radius. Okay, we mask this by that. And now you can see we have something like this. And if you play it, as you can see, the particles are attracting and go along this direction. Nice. So this is another important example. You have to work with a mask. We mask the because the mode of this arc is radius. It masks the radius around that curve, and just selected the particle that are in the radius of this arc, and they are moving. You can add any other arc that you want. Nice. You can change the strength, or you can go to the reverse it. Nice. So you learn a mask. Another interesting thing that you can control the position of the emitting particle in this by another particle system. So we are holding control to copy that emitter, and emitter number 1, we want to make it the 0 in this size. Going to this direction, or you can make it to 3D. It's not very important. Now, as you can see, we have 2 emitter. Emitter number 1, emitter number 2, that we want to control the direction of this particle with another particle in the field force. You can assign another field force here. In this field force, we want to control by this emitter. That's a particle object. So you can assign the particle object. Go to the emitter objects, and in a parameter, we have a speed there. Not very dense, a little object. And if you play it, it's going in that direction. And as you can see, the field force are affecting both of them, because in the field force is an emitter. So first things that we have to do in the z direction, we have to rotate it exactly in this direction. Nice. And we don't want to this field force affect this emitter. So what we can do here, you have to go to the emitter. We have an include tab. It means selected include nothing. If you set it mode to include nothing, if you play it, as you can see, that field force or any field force that you selecting does not work with that. And as you can see, they are going in this direction because in a field force, we controlling the you can set add a const absolute and going here, and in I think, yeah, you can invert it in this direction. Okay. No, invest, no. Okay, let's play it. And let's see, in a field force, you can change the strength. As you can see, we have an here. Going to the layer and change the radius of that particles to better see it. As you can see, any particle, oh, we are in 3D. Make the field force in the display exactly 2D. Make it dense. Nice. Change the length a little bit to see it better. Okay. They're going in this direction. Go to the emitter. Okay, I want to tell you just you can control the direction of that with the emitter that is shooting there. Nice. Okay. Okay, I change the radius and the strings, and now you can see uh, if I turn the emitter off, as you can see, at the this is one particle that emitter is shooting, and it's control the vector of that. It means go in this direction or that direction. You can reverse it at any time that you want. Okay. So it means you can control the direction of your, or add velocity or set velocity of your particle with another emitter here. And for changing the direction, simply go to the direction and invert the direction of the particle. So the particle are traveling in this direction that you want. Not, as you can see, because of the set velocity, you can add to velocity. It means, okay, it's accelerate the movement. And nice. You can washing your particles like this. So you can understand it's very easy. The particle shooting from here, that the field force does not affect this particle, and the particles are intersecting the field force and create a vector like this, create a vector, and that vector here, that vectors are controlling this direction, you can see. So it tells you, okay, the particle go in this direction. Okay, let's go to another example. Okay, in this example, I want to use attractor to the object. For example, I select a sphere here, and I want to control it some another sphere and then attract them to our main sphere like this. And let's see what happens. Sorry. Nice, simple things here. Attractor are also affecting things. I want to animate it. You can assign an animation viber tag and change the position it, as you can see. More position in this angle and some y angle. Let's see that. Nice, nice, nice. Let's frequency. I think 1 is nice. You want just hit them. Okay, nice. Nice, nice. I want to assign them, all of them, bullet tag, rigid body, if I blade are falling down. So for better moving to them, you can go to the force, follow position number, and of course you have to, I will explain them. So make the 0 of the gravity, and nice. So sorry for that. I have to turn this follow position for its 0. This is because the object that is moving, and it's falling down. Okay. What is happening? I think something. Oh, I think Viber tag. First Viber tag, then that. I think it's better to delete that tag. And oh, I changed its position. Why is this happening? Nice. Instead of the rigid body, I assign glider body. Yeah, that's better. Okay, I want to attract these tools, this let's try to make it bigger. This sphere to data sphere. So we can add an attractor force and make the child of that to move with that and affect all of the dynamic in the scene. So the attractor is that. Attractor The axis of the attractor is very important. If the attractor is exactly here and then make a child, if you make a child, it does not happen anything. Just we want to move with the sphere. And that's what happened. As you can see, it's attracting, it's trying to attract the other sphere to itself. If you increase the strings, as you can see. But the problem is this, that the attracting position, it's very important. We can give more object to better see that. It's attracting just in one position, okay? The attracting exactly in this area of that, okay? I want to tell you, okay, I want to attract object on all body of the this sphere, not a specific point. And we needed to make it, bring it that. We need to make a field force for doing that better. And we want to create a all body of this sphere as attractor to attract it. So let's what's happened here. As you can see, attractor is there, and if you change it, as you can see, all of the objects are attracting to this point. Nice. Okay. Let's try it. Assign the tilt attractor. We want to create an attractor with a field force. Oops. Let's try it here. Field force. This is our field force. Important part, as I said before, it is an area affecting. If your scene is like this, make the area of the affecting of the field force bigger. Don't forget that, okay? Because we want to tell, for example, this radius, please snap to that sphere. That vectors are ordering that vectors that you created here, ordering this sphere to snap to this sphere. So the area of that is very important. Going to the field force in the object, don't forget, don't drop it in the field. In the object, this main sphere. Okay, and as we can see, this we can see it's better. These are if you play it, these are the vectors that are that want to ordering the others to snap it, but because the affecting area is exactly at the surface of that sphere, they are not going to snap it. So we need to change the settings to all the effectors, all the vectors go all this area to force other object to snap this. So we have to make that vector bigger. So what we can do here, first you can make the strings bigger to more attraction. Select your sphere, and the interesting and important thing that is here in a direction. In a length of that vectors, we have a user value. It means, okay, use that value of the sphere to creating your vectors. In this case, we want to go no remapping. Okay, it means I want to no remapping that. I can make it turn it off. Okay, and as you can see, it's pushing apart all of it because we have no remapping. It's go to the infinite and affect all objects. So in the direction, you can change the direction. As you can see, if you change the direction, all of the spheres are snapping to the surface of your sphere. Because we use no remap, okay, it means please assign it to exactly whole area. If you turn this on, as you can see, we have these spheres. If you play it, as you can see, they are changing. It means it is an attraction forces that, for example, the objects are here, snapping to the, because of no remapping. And don't forget to reverse it. If it's attracting or repelling or push apart objects. So you learn it now, because the area of affecting of the field force is very important. For you can go to the display and make it a very lower number of your links here. Yeah, that make it better sit. Nice. This is our box. This is an area box that controlling that. Let's try this sphere in this area. That's what happened. Yeah, it's immediately a snap it because we use no remapping. In this case, if you use no remap, it's go to the infinite and the box of your field, that's not important. And these vectors are forcing all of the object exactly at the surface of that. As you can see, it's changing. And it forces all of the objects around that to attract to the surface of that sphere, because we set it as a volume here. As you can see, it's a volume, like this. Volume here. Okay, you understand it. It's very easy. It's the last example. And waiting for other tutorials that we make a lot of interesting other projects with this. You can do a lot of things with that. Hello my friends, to continue these tutorials on YouTube, subscribe us, like us, and hit the bell icon. And now you will be alerted about all of the amazing videos that we release.